Hi everyone, welcome back, and today we are going to see about the case study on valves and actuator in heating, ventilation and air conditioning applications. So here why the case study it denotes here the valve and actuators are the devices which is used for the positioning the valves. So here the valve actuator which can be used for whether it's fully open or fully closed, where it require and constant and precise control such as to regulating the flow of fuel, water, gas or something it may be. And the application of this actuator is it is an automatic process, and here where it requires large amount of torque which is to operate the valve or actuator, and this is which is used to protect from the dangerous condition at instantaneously, and it can be used to control the flow where the manual power is not impossible, and continuously adjusting the system that maintain the desired parameters. And these are the applications of valve and actuator. The types of valve actuators, it is an pressurized air or electrical power, or it may be a hydraulic force. So the selection of proper actuator, it is based on the following criteria. The one is valve applications, where we are using the valve, number one, and number two, the means available to the power the actuator, and what is the speed to activate to operate the valves. So the speed is the requirement, and the force which is required to the valve, it is another factor, and the type of valve which is to be operated in an HVAC application, and the last one, the cost versus benefit for using each type of actuator. So we have to go for economical, and these are the criteria while selecting the proper actuator for the HVAC applications. And this is a normal, or it may be called as manual actuator. So in order to control the flow of liquid, gas or something it may be, so manually we have to operate the valve. This is a normal or older method. And the automatic process, the first process is called pneumatic actuator. This is a pneumatic actuator. So the pneumatic actuator which uses the pressurized air to operate a valve. Here we are used as a pressurized air in order to operate the pneumatic actuator. Okay, so in this type of actuator, just we can see here this is an input and this is an output. Here the flow of liquid, water or it may be a gas which is entering into this valve, and from this end to this area to this area, this will be leaving. So during this process, here the gate should be open. So that here the high pressurized air which is supplied at the top of the actuator, so that the high pressurized air, it pushes the entire area, so that the piston it moves downwards. It moves downwards, so that the gap it will be closed. So that we can able to control the flow of liquid or water or it may be gas. And if you go for the second figure, here the flow direction is like this. But here the valve is closed, so that here the high pressurized air it will be supplied at the bottom of the actuator. So the high pressurized air it expands the spindle moment, so that the spindle it moves upwards, so that here the valve gets open, so that the flow of liquid or water or maybe gas it leaves to the actuator. So with the help of with the help of this high pressurized air, we can able to control the valves so that the flow of water, liquid or gas, it may be controlled in a pneumatic actuator. Okay, and the advantage of pneumatic actuators are it dependability and the simplicity of the design. The design is very simple and it is very fast to operate, and the fire is hazard is also very low, and also it is most economical method. Okay, so the pressurized air can be stored, so the valve can be operated when the power is lost. So it is can be operated at any time. Okay, and what is the disadvantage? The performance at low speed. The performance is very low at the low speed, and the compressibility of air, which may be lead to the inconsistent speed of shaft movement. Okay, so these are the disadvantage, and the applications due to their simple design and high reliability and low cost, pneumatic actuators are used in many industrial applications. For example, pneumatic actuators are often used to control the cooling water flow in power plants. Okay. And this is an electrical actuator. So in electrical actuator, so the valves can be controlled with the help of an electrical motor, which are coupled with gear coupling, which are coupled. Okay, and the advantage, there is no source of pressurized air. The pressurized air is not needed in order to operate. Okay, and it is capable to produce very huge amount of torque also. The electric cable are very easier in the piping to route the actuator. Okay, and this is the actuator. So based on the switching operation, we may operate the electrical actuator in forward and reverse direction, as well as on and off control. Okay, and this is a disadvantage. It will be more expensive when compared to the pneumatic actuator, and the potential fire hazard is also available in this method. And this is an hydraulic actuator. So there is a pressurized fluid which is used to control the valve of HVAC applications. And the advantages are, it will be more powerful than pneumatic actuator of the same size, and it is very precise control of valve position, and it is capable of converting the small input pressure into the large output pressure. Okay. So the disadvantages are external hydraulic pump, which is required, it is mandatory, and the efficiency can be influenced by the change in temperature, and it may be leak, so that the potential of fire hazard is very high. These are the few reference textbooks for this topic. Thank you.